Hello, welcome SREday. It's nice to see you all here. Hey, I'm Michael Meelis. I'm a platform engineer and I work at ITQ, but enough of that. So, who here is enjoying themselves? Right? It's a good day, right? But I'm going to change. I'm going to change that because all of you, including me, we have broken the laws of IT. And let's review. And for me, in this case, I'm going to take you to court. Welcome to my court. And in my court, I will be the judge, the jury, and the executioner. So who here grew up in the 80s, 90s, and has seen the original Marvel movies before they were actually good? Yeah, anybody here? So who recognizes this? Judge, jury, executioner? Exactly, but maybe some people already saw this talk. So I don't know if anybody recognizes him. It's Judge Dredd from the same movie, and the catchphrase, I am the law. So I'm going to be here and I'm going to judge you all. But first, before I can judge you all, let's review what kind of laws that can be broken. So first off, we have Murphy's Law. Not technically an IT one, right? So everything that will go wrong goes wrong. This is something that happens in IT. This is something that happens at home with anything. So let's look at the, I think I will stand here. I feel like I'm standing in front of it. Brooks Law. I don't know if anybody read The Mythical Man Month, but this is very common in IT. Is let's add some more people to it, and then we will solve the problem, right? Wrong. That usually doesn't, it usually delays it. So Andel's Law, that's something that is for software engineers for us. So if you want to speed up something, there's only a limited amount of parallel processing that you can do to actually go on. So then you have Knut's optimization principle, a principle, but a very important one. If you start optimizing early, you will start making complex things and you'll start delaying and you will start building bad code. Then we have Moore's Law, which many people have said, oh, this is not going to continue. It will break, it will go on. It still is valid and it still keeps on going. So then we have Pareto's principle. So the 80-20 principle, which you can apply to almost literally anything. So in this case, I'm pointing at you guys. So 80% of a company usually exists of developers, right? 20% is only the other overhead of it. So when I'm pointing at you guys, I'm saying that we all broke these kind of things. And if I'm pointing at you guys, there's also 4 fingers pointing right back at me because I am also responsible for all of these kind of things. So let's continue. The most important law. The most important law that's been broken and that we've all been faced with is Conway's Law. So here, who here doesn't know Conway's Law? Okay. So Conway's Law is very simple. The guy actually did this in the 1950s, 1960s. It's a very old thing. He says that the way that your organization looks is actually reflecting on how your architecture is going to look like. And in the beginning, he wasn't dealing too much with software architecture. He was more dealing with processes inside of a company. And later on in his life, he started looking at it. Let's judge it. Let's look at Conway's Law. Basically, what Conway's Law says is that the bandwidth of communication needs to be open. It needs to be wide. And how can you do that? You can have a lot of communication inside of a company, but you have to have a way of doing a proper communication because just talking is not enough. So if you start making it smaller, so you make it into teams, you divide the communication, right? So that means that the bandwidth is lost. But that isn't always a bad thing, because if you lose bandwidth, that means also that all of the chatter or the meaningless things get lost. So how can we deal with this? How can we go on with it? So who here knows this guy? I guess we're all IT people here, right? What was he famous for? Exactly. So I'm going to change this around. I'm going to stand here and I'm going to say communication, or in this case, C4 architecture. So I don't know if anybody knows C4 architecture in here, but that's a small joke in there. So how do we deal with Conway's Law? the way we deal with Conway's law, and that's how most people deal with it in the beginning, is just completely ignore it. It doesn't affect me. Why should I deal with it? The second way to deal with it is just to accept it. And it's okay, now we know this. How are we going to pick this up? And how are we going to deal with it? I don't know. But there has been some progress from the past and to the future. And I want to show it a bit by how the software architecture used to be, or how people used to do things. So I've been going on with a long time already, and I've been part of the development cycle like this. So we have a front end, a back end, a database, and an ops team, right? All of these teams were separate, especially in the old times where people developed their application, threw it over the wall, and then the ops team had to deal with it and try to deploy it. And the same goes for the database. It was one huge thing that everybody started plugging into with the monolithic application. So how does it look like? There are multiple UIs, multiple APIs, and a database and an ops team separate to it. So this was a lot of communication overhead, and in some cases not even communication between the ops and the application developers. So how can you deal with Conway the third way around? And this is much, much more difficult. And to be honest, I haven't seen it implemented properly. So the inverse Conway maneuver actually says, let's use this knowledge and let's try to implement it. And let's try to make dynamic teams. Let's have it be fixed in the way that it should be. So let's design the architecture and design the teams. But yeah, anybody who works in an enterprise knows that there's a lot of middle management, a lot of other layers inside of it. Try designing against that. So that's a very difficult thing to do unless the company is open or a bit smaller to go through it. So let's go a little bit over what did go right, how we did design things. I'm glad that somebody already in the previous presentation says that DevOps engineer. I find that a terrible way of naming somebody. And it's true, DevOps engineer is not a role. But in this case, DevOps is something that a company can do. And DevOps means that you place the responsibilities inside of a team and have the team do lots more stuff. So in this case, let's go back. Let's have a front end, back end, and in most times a Q&A, because that's also important. And if you look at it, you can implement the DevOps methodology on top of it, like I said. And now I'm going to do a little bit of a quick reference back. I don't think anybody here saw my previous talks, but in a previous talk, I placed this slide here. And if you're curious, DevOps is a methodology, not a role, exactly the one that I'm referring to. I'm going to be giving this talk next week during the Dutch Cloud Native Days. So if you're curious what I'm talking about, then please come. And let's get back to the microservices architecture. So the microservices architecture shows that the team can actually deal with all of the stuff that's there. So you have a person who is knowledgeable about how to deploy some infrastructure. Or if you have a platform team, you have a platform team supporting you with the tools to actually deploy and then do the other stuff with it. So in that way, the team has a lot more control about what they're doing. So your org chart needs to be flexible. Yeah, if you want to deal with Conway's law, you can try and continue on with this, but it's difficult. But the realization that you can get from this is that your organization affects your software, can be eye-opening, and you can try and change with it. So let's go on. I will leave this here. Usually, like the other people said, I talk fast because I'm Spanish. I talk fast as well, but yeah, honestly, I'm Dutch. And this is usually a bit of a breather for me. And this is very to the point of what I'm trying to say. The second part, domain-driven design. How can we solve this whole problem? Because as we saw, Conway's law applies to most organizations. But to actually implement it or to start using it, you have to be aware of what your product is, of where you're actually going. So who here has worked with a domain-driven design, or actually, that's nice. It's always good to see. Domain-driven design actually says that the structure of your code should actually reflect what you're doing. So that means that if you're trying to implement domain-driven design, that means that if you're writing code, that should reflect what you're doing. So that you have to go into the domain and you have to start looking into where am I going. So Domain-driven design is a very complicated implementation to do. There's lots and lots of stuff here. There's event storming, there's context, domain, there are bounded context, all these kind of stuff. And I won't bore you to death with all of these parts of it. I do highly recommend to read the Big Blue Book and go through it if you want to implement it. Let's look at how we can use domain-driven design. So if we look at it from a real-world perspective, you can have a support system. And in that support system, you have to raise a ticket, you have to log into an account, and then we have a booking system that's next to it. So somebody actually wants to book something, you buy a ticket, and you pay with an account, and you go to a platform. So if we look at this from a train, in this case a train perspective, that means that if you want your software to reflect all of this, that means that you have to follow all of this stuff and make sense of it. So let's go on and look at it even more if you want to implement this into code. So let's say we have 3 platforms where the train can land. Every one of these platforms has services there. Toilet, maybe one has a shopping, and the other one has some drinks. Now, if we want to have this reflect in our code, it already becomes difficult, right? We have multiple platforms here, and sometimes when you come somewhere, you have a platform that covers all of the platforms because we name it like that inside of our normal language. So how are we going to deal with this inside of code? But let's push the example a little bit further and look at it. So we have a train. A train has a destination and a platform. And then we have a passenger that wants to buy a ticket, and that ticket has a price to it, which goes into a train. As you can see, the complexity of all of the real world terminology or the real world complexity has to reflect into the code base. And it becomes quite a difficult thing to not overlap certain terminologies inside of a code. So you can even go further. So let's have a cleaner. And that cleaner has a shift. And that cleaner has time inside of it, and it needs to clean several parts: a platform, a cafe, and a shop. But wait, there's more. Yeah, there's a shop there. So that shop actually has to serve for a product, and it has customers as well. So as you can see, I divided everything up, and you can see where this is going at. We have to separate them out. We have to put bounded context there. And actually, with these bounded contexts that you can see here, we can already specify certain domains inside of it. And you can start putting priorities to these bounded contexts as well. But they do overlap. So for example, a shop in one part can exist also in the other part. So these things bridge each other, and they can be reflected in code. The same can be for the passenger and the customer. But if we separate them out like this, it means that we can actually have different parts talk in different ways from each other. So let's look at it. We have 3 parts here. And these 3 parts, like I said, can have different kind of priorities. And these are very important for your product to have. So on the left side, we saw all of the parts that were related to the train. So this is the core of your business. And this is the part that you actually want to have and should focus on. So this is something that you can have inside of a team and say, okay, this part inside of my organization is very important. And then you can separate the other part out as a supporting layer. These things are not adding too much on top of your original product or on your original domain, but they're supporting. So you don't spend too much time on it and you outsource some parts of it. And there are even some things like maybe the shops we have in NS. Yep, you can just say, let's outsource it completely. They're generic. We're not going to spend time on it, and it should be there. And now you have neatly divided places to put inside of your software as well. And you can divide these into different domains inside of it. Now, the third part, me executing it, finally, we have a solution where we have 50 people determining what 5 people should actually. This is the solution. I think I'm done, right? No, no, not really. Yeah, to be honest, who here doesn't know SAFe? Good. Yeah, this is definitely not a solution. I think this is exactly the opposite. This has too much overhead in communication whatsoever. let's mash it up then. Let's put the three parts together. So we have Conway's law. We have the C4 architecture. Yeah, not that one, but that one. And we have domain-driven design. So if we combine it all together, we can look at how can we choose the optimal parts of it. So the inverse Conway maneuver, like I said, yes, it could be an option, and it could be something that you could open up with your manager or with other places. And you can actually show them, okay, this actually reflects how we want to do things. But it's difficult. And I think it can be slightly impossible, but you can be preventative. You can say, okay, let's not grow another team, or let's not put more middle managers in between there, and let's have this open. What we can do is put more responsibilities into a team and have the team drive itself. So for fun of it, I just put biz, dev, sec, ops there, which basically I'm trying to say is that you want the communication for your product and for your development as much as possible inside of a team, so that you don't have to go out through the org chart and talk with other people there, because then you're limiting yourself, you're limiting your progress, and you're limiting your forward parts. But yeah, it's a very big curve and maybe not even possible. Nope, I'm going a bit too fast. Domain-driven design. This is one thing that I would highly recommend any company to do, because if you don't have a view of what your product does, if you don't have a sketch or a schema, or at least an idea of which parts communicate or interact with each other of your company, then what are you doing? You need to know what your domain is, right? You need to know how to go forward. You gain a lot of insight, you gain a uniform language into how to do things, and it can actually maybe give you a new structure for the development teams. So you can actually organize them and say, this team is actually going to do this part of the domain, and this team is going to do that part of the domain, and we make the communication between those teams easier because they have an overlapping part there. It's difficult to start with. There are definitely ways out there with event storming and other things to actually achieve this. So I would highly recommend, but it does have some complexity to it. So did I actually implement or do stuff of this? In a way, yes and no, because it's difficult to achieve on a big scale. But at RTL, where I've worked for 6 years, I tried to implement domain-driven design from the beginning. And they were pushing me away and said, no, this is complicated. We don't want this. So I started doing it as a platform engineer there. And I started separating things out, having Kubernetes namespaces for the teams that actually want to do this kind of stuff, and have it separated out on the domain instead of the team name or something like that, which gave them Terraform repositories, or at least an interface for a platform where they can start using these kind of things. So this was it for me. I'm Michael Meelis. I'm open for questions. Postel's law, the last one. Be conservative in what you send, but be liberal in what you accept.